harnessing the power of nature. Clean, renewable, infinite. Wind energy powers our future. Wind energy turning dreams into reality. Wind energy as a renewable energy source. Wind energy is a form of renewable energy that harnesses the power of the wind to generate electricity. It is one of the cleanest and most sustainable energy sources available today. Key features 1. Renewable. Wind is naturally replaced and won't run out, unlike fuels. 2. Clean. It produces no greenhouse gas emissions or air pollutants during operation. 3. Sustainable. With proper planning, wind farms can operate for decades with minimal environmental impact. Low operational cost. One installed wind turbines have low maintenance and operational cost. How it works? Wind turbines convert the kinetic energy of the wind into mechanical energy. This is then turned into electrical energy using a generator. What is a wind turbine? A wind turbine or wind generator or wind turbine generator is a device that converts the kinetic energy of wind into electricity. Parts of a wind turbine. 1. Blades. Capture the wind's energy. Rotor. The blades and hub together rotates as wind blows. Nacelle. Houses the gearbox, generator and controller. Tower. Supports the rotor and nacelle high above the ground. Generator. Converts mechanical energy into electrical energy. Anemometer and wind fan. Measure wind speed and direction. Yaw mechanism. Turns the turbine to face the wind direction. Types of wind turbine. There are two basic types of wind turbine, one horizontal axis and two vertical axis. Horizontal axis wind turbine. Horizontal axis wind turbine are the most common and efficient type of wind turbine. They typically have 3 blades and operate upwind, which means that the blades face into the wind. This is because the head of the hod can pivot thanks to the yaw system. The main components are located at the top of the turbine. Vertical axis wind turbines. As the name suggests, vertical axis wind turbines have a vertical rotor shaft and their appearance is very different from that of the more traditional HAWT. VAWTs are omnidirectional and so they don't need to be adjusted in order to face the wind. These can be an asset in locations where the wind direction is very variable. They are, however, relatively rare as they are less efficient in terms of air distance. The main components are located at the base of the turbine. What are the wind turbine's main components? The foundation. This is a large, heavy structural block of concrete in the ground that supports the entire turbine and the forces acting on it. In offshore turbines, the foundation is underwater. The tower. The tower is usually made of steel, although wood can also be used. The tower usually has 3 sections and is assembled on site. Its height varies, but it is generally the same as the diameter of the circle that the plates create when they spin. The tower also contains the power. The tower also contains the power cables that connect the nacelle to the transformer on the ground. The nacelle. The nacelle isolated on the top of the tower and can turn 360 degrees on its own axis. Depending on the direction of the wind, it is named after the part of the wing of an airplane that contains the jet engines. It houses key mechanical elements, the gearbox and generator, a rotor and hub. Rotors with two are cheaper and faster than three blade rotor. But they are also noisier and they vibrate as with the propellers on airplane. The hubs, the noise that points forward at the center, the blades are attached to it, and it is in turn connected to the mechanical parts in the nacelle, which is located behind the blades. These are located on top of the turbine. The average length is 170 feet or 52 meters. Wind causes the air pressure on one side of the blade to decrease, and the difference from the other side creates both lift and drag. When the lifts are stronger than the drag, the rotor will spin. How are windmills built? The construction process is complicated and requires both cooperation and precision. The associated components are manufactured and then transported to the site. First, the tower must be assembled, after which the nacelle and its components are placed on top of it, followed by the blades. Last but not least, the utility box and electrical system are installed. Advantages: 1. Reduces reliance on fossil fuels. 2. Helps combat climate change. Creates jobs in manufacturing and maintenance. 4. Can be deployed on land or offshore. Challenges: 1. Intermittent energy supply depends on wind availability. 2. Visual and noise impact. 3. Requires suitable locations.
Thanks for watching the video. If you learned something new, give the video a like and share it to others. Subscribe for more science and technical tips. Show tap the bell icon so that you don't miss anything. Let's power the future together. Our next topic will be hydropower.